There we go. It started. All righty, everybody. Well, welcome to today's Lunch and Learn. I am Steve Lander, Director of Pavement Management for Withers Ravenel, and the topic we're going to be talking about today is innovations in asphalt materials, mixtures, and testing. And if you're a pavement geek like we are, you're going to really like this topic. All things pavement. So I hope everybody's doing well. And the intent of these lunch and learns, and we've been going since January of 2021, and I think this is number 37, is to introduce new practices and products. So the goal of today is to hopefully you'll learn something about testing and the mixtures. And the bottom line here is to produce mixes that last longer, and at the end of the day, it costs everybody less to maintain the roads. So, which in the chat area, we're going to be posting a few links and 2 email addresses. So the first link is for if you need PDHs, you could just click on that link. It'll take you to a form and you'll get PDHs, a PDH for today. The Withers Ravenel website, Blankenship, their website is there. We have Phil's email address and my email address in the chat area. So that takes care of some of the house cleaning. The lunch and learns are all recorded, as you heard me say at the beginning. So if you have to jump off and you want to watch this again, or you want to provide this to others, we can get you that link so you can watch it. And we can also get you a copy of the presentation in PDF format. The PowerPoint version is ginormous. It's like 380 megs, so it's a big file. Also, too, as we go through these things, we ask folks for input on topics that you might think would be good for us to present here. So just let us know anything we can improve, or if you like it, let us know that too. That'd be great. So the format is that Phil is going to be speaking for about 40 to 45 minutes, and everybody's on mute. So if you do have a question, just put it in the chat area, and then Deanne and myself, we're going to help Phil if it's apropos to what Phil's talking about, I might just interrupt Phil, and we can hopefully have a conversation about this rather than just a dry presentation, which it might be if there's no questions, but we welcome the questions. So introduction for Phil here is he's the president and owner of Blankenship Asphalt Tech and Training. He's a graduate of the University of Kentucky, right? In 2017, he started Blankenship Asphalt Tech and Training as a consulting engineering company that uses his agency, industry, and associated combined experience. He's involved with several committees on boards, TRB, which is Transportation Research Board, Association of Asphalt Pavement Technologies, and different boards for ASTM. So with no further ado, I'm going to welcome you, Phil.
Thank you, Steve. We running around today in Owensboro, Kentucky. So pardon me that I don't have my big University of Kentucky sign behind me, and don't have my Batman symbol, right? So
yeah,
I don't have my Batman symbol. I have to bring it up this way, right? So
yeah, do a little improvising.
Yeah, you got to do with the bat pin, right? And
yeah,
all things Batman. I even carry one on my keychain. So
there you
go. If you have a name like Bat Lab, you got to have a little bit of fun with it. And if you're not enjoying what you're doing, you need to change jobs. So
exactly.
That's why I do what I do. There's actually a statistic out there, Steve, and it's the number I heard was 70%, maybe 75%. It was high of folks who are employed. 75% of the folks who are employed are not happy in their job. So the message from that is find something that you really enjoy doing. If you're an engineer like myself and you've done something for 30, 35 years, you're probably stuck with it. So find some happiness in it somewhere. Okay, here we go. Innovations in asphalt materials and mixtures. Um, I appreciate you all allowing me to host this today, and glad to get to join you and share this one. This is one I really when I do speak on it, I always are throwing new materials around. I found out that it's helpful just to take a look at what's out there today and sort of what's floating around in the additive world and what's coming.
And also, too, noted is this is something that Phil could talk on for about a day, and so he's going to cover some of these topics rather quickly. So, wet your whistle, right?
Absolutely. Let's do it. A little caffeine, and so we're gonna go over first, talk about some of the challenges that we have and the need. I always believe in that you can't talk about solutions and benefits unless there's a need for it, and so we're going to start off with that. Then we're going to look at modern testing and then modern materials and mixtures. As we begin looking at then the newer products that are out there. And that go along with that, and then some demonstrations that we have. And as we get into some of those newer mixtures, materials, and products, talk about some of the demonstration projects it's been, and then sort of what's next. Einstein said creativity is intelligence having fun. So very first thing is that we get in the laboratory. I know my crew, they said one of the things that they enjoy the most in working at my company is it's not a routine. And sometimes that's good. Sometimes that can really throw us for a curve when you get something new that comes in that you've never worked with before. But yeah, Albert Einstein said that, and so hopefully we're enjoying what we're doing. When I started on the topic, one of the things I realized is that innovation really depends on who you ask. If I'm talking to an agency, they agencies say, you know, I want much longer life at less cost, but best if it's not proprietary. Contractor is going to come at it, and I'm working with a group right now on an airport project, and here in Owensboro, and as I'm doing it, you know, one of the things that they continue to say last night is that once we lock into a process, let's not change this. Especially you think about some of the penalties that come with some of the larger projects. If you look at the state of Kentucky, we're a minimum density state. If you look at states such as Indiana, they're percent within limits. P401 specs with airports are percent within limits. So not only do you have these minimum thresholds, but you have these statistical limits that you've got to stay consistent. So the contractor goes, I've got to have better control of the mix at the plant. I got to make sure it's easy to use, haul and compact. Oh, more use of wrap. And by the way, don't slow me down. So the contractor needs something that's consistent, easy to use, allows him to keep running, and now more use of wrap. The private property owner comes in from a whole different side, almost just the opposite of an agency. They're saying, let's go. Matter of fact, some of the ones that act somewhat like a private group are tollways. They're looking for more sustainable options. They're looking for quicker options, better options. An example of that, and I don't have that one in here, but I'll share verbally. Pennsylvania Turnpike Authority just said they've got to fix their stripping problem. And they did some quick experimental work, and they found out that salts are greatly affecting the stripping and the chemistry of their mixture. So they brought on a new product. It's called Zycotherm, a very different type of additive that you put in to help the asphalt to bond better to the aggregate. Not traditional amine-based chemistry that we've used for 30, 40 years. This one comes in a whole different way. Once they found out that it was going to work, and they did the testing on it, and they said, well, this is a no-brainer, let's go with it. They switched their bids in 1 month. So I think over in April, they flipped everything over that fast, and it sent the market into a tizzy. Contractors are going, where can I get this stuff? How do I get the stuff into my mixture, and how do I do all this? So realize folks like turnpike authorities can operate really fast, whereas if a DOT made that decision, you're looking at that over a period of years to implement. You even go more private. You may look at a university, you may look at a Intel, Love's Truck Stops, things like that. They may come in and say, cost is not a real issue if you can make sure that performance is delivered and this is going to last longer. And by the way, I want it green. I don't care what plastic does to it. I want plastic in this. You just make it work. And by the way, it needs to last as long as the current one did. So that puts a lot of pressure on us. So again, when you say what's innovation, you get really a wide variety of answers on that. Challenges that we have today comes at us pretty hard when we look at what we call this traffic and load growth on the rural interstate system. The blue line represents average daily traffic, ADT, or it's just number of vehicles. The average daily load represents the load from the trucks. Okay, so one is a number of vehicles or volume, while the red line is talking about the load. And keep in mind, one 18-wheeler loaded 80,000 pounds is doing about as much damage as 4,000 to 5,000 cars. That blows you away. It's not that it's 4,000 to 5,000 times heavier. It's the stress bulb that it puts under the pavement and causes the damage underneath. If you look at that change since 1970, we did have a peak right at 9/11, if you see there. And at 9/11, we peaked on the blue and then we dropped off. And this is on the rural interstate. So you go into the city and everybody's going, no, I'm still seeing a lot of traffic. But on the rural interstate system, the number of vehicles did actually drop off. You're talking about per lane. We built more lanes and we've done all that. But you look at the overall traffic and it's gone down just a little bit. As you look at the rural, probably took a little more dive at COVID, and then it's probably popping back up. They just run the numbers. It takes them a few years to catch up. When you look at the rural average daily load, it is jumping up there over 750% growth since 1970. So it's not that we're not designing things correctly, and we can definitely make improvements. But what's really going on is we have a growth that we have to plan for that we weren't ready for. So a lot of times I know, we're taught 10, 15% growth on things, and you estimate things along that line. In this case, you're looking at something that's going back 40, 45 years here, and you're looking at over 750% load growth. So then you go in and you look at our infrastructure that was put down in the 50s and 60s. We've redone a good portion of it, but there's some of it that still exists. And our job is to maintain it. Maintaining it could be preventive maintenance. It could be simple mill and overlay. Maintaining it could be going in and taking out a significant portion or all of it and replacing it. Well, we build more roads, we build more roads, we build more roads. And all of a sudden we have less agency. You have workforce issues right now. We can't even get truck drivers in some areas. And ASCE comes in and says, hey folks, you're not doing a good job on your roads. We're going to give you a rating of a D. That comes at everybody in the industry, including the agencies, on maintaining what we have. This is what was taken to the Hill or taken to Congress to ask for the infrastructure bill that we have today that released more funds to help us with our roadways. They gave a lot of facts to help understand this. And they talked about, nation's highways and roads moving 72% of the nation's goods. The average, the vehicle miles traveled reaching more than 3.2 trillion. And I think the number, I don't see it in there, but it's somewhere like the average car is moving somewhere around 18,000 miles a year. Here's a big one that you're looking at. It's an important one. It's the lower point. Every lane mile of roadway cost approximately $24,000 annually to operate and maintain. $24,000 per lane mile. Out of that, we ended up with a D rating, 43% of the systems in poor or mediocre condition. We still have fatalities going on, so that's why again you've seen folks began to look more at things like friction and tools like that I'll mention. 27 states are saying, hey, we're going to depave some roadways because we can't keep up with all this. There's that the mediocre to poor range, the 40 almost 43% we're talking about. And if you look at what's in the fair category, you're looking about 58% is in this category, where only 42%, 41.9 is in good condition. So what do we do? Do we, now we've got all the stress of we've got to go lower carbon, and what do? Well, insanity is continuing to do the same thing and expecting something different, right? So what do? Well, we just need to keep doing what we're doing and build more roadways. And absolutely not. ASCE said something's got to give. So here's what they recommended. Focus resources on preserving a good state of repair. Now, we know we've got to go in, and Steve and the audience, okay? We've got to go in on roadways that are not aligned properly. The old roadways, and there's one where I live, goes to a small regional airport, and it goes around. Here's a farm, and it's got to go. It wraps itself around to get to the airport. We've got to fix alignment issues. So they're not saying don't do things like that. They're saying don't go and add more lanes on and encouraging more people to drive, causing more carbon, putting more money. Now you've got an extra $24,000 per lane mile to maintain. Focus on resources on preserving a good state of repair. So let's try to bring this good from a 42% up to 60, for instance. Increase funding from all levels of government. We have not had a funding increase from Congress since 1993. Now we have all these emergency bills to go through, but we haven't had a base funding increase since 1993. And then, of course, they say develop state and local comprehensive asset management plans. Easier said than done. That bottom one is a mouthful. The bottom one is basically saying, if we give you money, develop a plan on how you're going to spend it. There's Everyday Counts initiative that's been put out by the FHWA. This has been out, I think, about 6 years now. Tim Aschenbrenner really heads a lot of this up. It was Colorado DOT, and he's now with Federal Highway Administration Regional Office. And what he's looking at is timely preventive maintenance of roadways, creating smart pavements with sensors. I've got a friend in the industry right now. They have cores that you can drill, put the core in the roadway, some glue around it, and it's going to give you the temperature at the different levels. There's some that you can actually put load sensors on. It's got moisture meters on it. So is my pavement getting wet? At what layer is it getting to it? What's going on in my roadway? When we find that information, we can take that sensor out, go put it somewhere else to better understand another pavement. So we have more data coming at us than ever. So we can design and talk all day long, but we've got to get out there and make sure that we put these things into action. Next generation materials, I'll talk about that here in just a moment. So he said simply for asphalt, SMAs, stone matrix or stone mastic asphalt, is really important to increase service life. Not every state can do it because you have to have pretty good aggregate to pull this off. But for the folks that are doing it, you're looking at a material that instead of right now we're getting, I want to say 7 to 8 years pavement life out of our surfaces. Now you're getting more than that in the base, but on your surface, I think it's a number that we're replacing the average of 7 to 8 years. That's not acceptable. We can get those numbers up at 12 and 15 years. Now, at some point, it's going to start to ride rough. No different than concrete when it gets out of section. Or you're going to have issues with skid that we're going to have to restore skid to it. So what triggers the overlays on a roadway? It's either it's falling apart, it's lost its skid, or it rides rough, or all three. When you measure the ride with the International Roughness Index, IRI as they call it. So SMA is one of the tools that we can put in place to make that life cycle longer. Another thing is the agencies have found that a modified asphalt overlay or thin overlay is more resistant to reflective cracking. They call this a crack attenuating mix, or a CAM. There's a version of this which is a RCRI, reflective crack relief interlayer, and that's what I had talked about last time. And that's where we go in, and that's it right there, where we can go and use the interlayer as about it's designed to be 10 to 15 times more flexible than regular surfaces. So when you combine the interlayer with the SMA, when you have a reflective cracking issue, you really get a winning combination. So these type of options are out there for us. All of this comes at a time when we have been told that we have got to look at sustainable options. We have to go for net zero carbon by 2050. Some people say it's achievable. Most say there's no way we can achieve net zero by 2050. But we've got to do something. Just because we can't achieve it doesn't mean that you don't aim for it. This is a tough one. This is a picture of a quarry in, let's see where this one is. This is in California, Southern California. Notice there's water in this quarry. This is an active quarry, by the way. Why in the world is there water in it? Well, when you're dealing with Los Angeles area, they have to have water. They have to refill their reservoirs at certain times of the year. So one of the agreements when this quarry was built was that it was going to be a partial holding pond to get water from the mountains to here to get it onto to get the water onto Los Angeles County. So for 3 or 4 days, I think it's a month, they have to abandon operation, allow this to fill up with water, and then pass it on out. This pit here is probably out of service now, or will be soon. If you begin to look at this map, and it's really it's not meant to be where we're going to go micro looking at all this. All these little things in here and the size of these tell us how much aggregate is going to be left and what's going to be permitted. Los Angeles County has less than 8 years of aggregates remaining unless they get new permits on aggregate. Less than 8 years. So what are you going, yeah, exactly. What are you going to build houses out of, buildings, roads? So there's a squeeze coming in. Not only that we're going to have to use recycled materials in roadways, but it's going to have to happen in some type of vertical structure. I don't know what this is going to look like, but they are getting some new permitting. But this life that we had where we're out there with 20 and 30 years of permitted aggregates is really starting to squeeze, where folks are getting really nervous. And this is all from sponsored by the California Asphalt Pavement Association that sent this over to me. This is a tool, and I'm going to let it play here just for a moment.
Hey Napa, your go-to expert on asphalt pavement, developed by XBE in partnership with the National Asphalt Pavement Association. It's not just a chatbot, it's a smart collaborator that stays up to date with the latest research and publications. Hey Napa can answer a wide range of questions, from the technicalities of asphalt production and paving to industry regulations and trends. It simplifies complex topics and offers step-by-step guidance based on best practices.
So, Hey Napa is a tool that stands for the National Asphalt Pavement Association. You have a couple of different organizations. I'll explain those here in the asphalt world. One that you hear about is Asphalt Institute. That's where a lot of our publications come from. Asphalt Institute is the industrial trade association for the liquid asphalt suppliers, or your refiner group. There's lots of other members. National Asphalt Paving Association is the industrial trade association that we tend to think about for the producers and the laydown contractors. Then you have your aggregate associations too. But between Asphalt Institute and NAPA, there's a lot being developed. I heard Asphalt Institute's developing one, or they already have a chat bot too. But taking advantage of AI. AI is more than a Google search. So I can go in here and say, hey, let me find out what's the latest on plastic, and it's going to pop up and it's going to tell me there's stuff happening down at the National Center for Asphalt Technology, NCAT. And you say more, and it's going to dig more. Give me references, and it's going to take that information and give you references that go on with it. So these are really good tools that are out there. So take advantage of those. When you think about innovations, let's go now into modern testing. This is my humble abode that I that I have in Richmond, Kentucky. This is a 6,000 square foot facility, of which about 4,500 square feet is laboratory. Everything from my aggregate lab to my mixing lab that you see here in this lower corner. This is a large scale slab compactor that we use for friction testing. I'll show you more on that in a moment. This is where we can go in and do the final testing, whether it's looking at crack test, rutting test. I can do rutting over here too. This is polishing that we do. One of the devices you don't see in here is a scuff tester. This is an auto analyzer. This allows me to wash the asphalt off. So it replaces the old extraction and recovery. Because guess what? Some of these chemicals are now on the list to be banned. But we would go in and begin to clean the asphalt off the rocks and do this forensic analysis, or even tell you how much asphalt, what the asphalt content of a mixture is. This bottom one is my binder laboratory. A lot of folks may not have seen these. When you're dealing with liquids, interestingly enough, makeup, paint, ketchup, bourbon, you think of a liquid. The study of liquids, if we're in the engineering world, as we're looking at it with civil engineers, we're taking something and we're putting a beam and we're putting a load on it. We're measuring something that's rigid. But what about it when you do look at a liquid? Well, you have to have rheometers that are actually have shear plates on them, and that's what these guys do. And this is a bending beam rheometer, and these are dynamic shear rheometers, and this is blending where we can do formulations in different aging ovens. This is the Hamburg wheel tracker that's going to run back and forth over samples. I know there's probably a good number on the webinar today that has seen this before. These devices are really useful. They came over. They came from a European scan tour of what was going on in Hamburg, Germany. I actually got to meet Professor Dahm, who was involved in the inventing of this from Hamburg. And the goal of this device was simple. It was they had to have something in Hamburg to be able to withstand a mixture that had to withstand intersection loads. So if it could pass 5 millimeters of rutting in this device at a certain temperature, then it was good enough for a 5-year warranty on an intersection. That's what it was developed. He had no idea in the 90s, late 80s, 90s, that how this was going to be taken off through the U.S. today and then into other countries. Ideal CT, this is just a fancy, what we call an IDT jig, indirect tensile strength jig. But the load cells and travel, now we can calculate with the computer that runs this thing. We can go and begin to calculate the area under the curve and the slope, and that allows us to do and help to understand the ductility of these mixtures and begin to understand the cracking index. If we want to understand pavement modulus for design, we have units such as what you're seeing here that we can instrument samples and begin to understand the dynamic modulus. As we pulse this sample, I move it, and if I move it, how much load did it take to resist it? And I can pull the modulus off this. I can also run more advanced flow number testing. You can glue the sample and begin to pull it, and I can run fatigue testing on these samples. I mentioned about friction. This is the slab compactor, and this is an actual polishing machine here. And then once I polish my slab, I take this device on the right where it's actually setting up, so you can see the bottom. You can see the rubber pads on the lower right. And when I put it down, I can either put it on the roadway or in the laboratory on this slab that you see. And by doing that, I'm able to understand the friction. This is something that we could not do 20 years ago. So now we have these tools that's coming into our laboratory that allows me to not only look at rutting, cracking, but now I can bring a third leg onto the stool and understand friction. Why is that important? Remember, we still have 36,000 traffic fatalities a year. And if we can help reduce those just from a simple design parameter by measuring friction, let's go. These are just services that I offer. Do a lot of training. I have not, Steve. I haven't figured out anything to fix fault lines yet.
Yeah.
That's actually from an edge of a volcano. I took that picture, but I said I've got to put it in here anyway.
A very large transverse crack.
Yes. This picture comes from the island of Hawaii, and that's actually near from the Big Island where the roadway gave way up there. I said, yeah, we can't fix that one. Mother Nature took care of that crack in a big way. I mentioned about extracting and recovering. I'm gonna show you this next video. Now, this is the recovery device after I get the effluent out of here, or the solvent and the asphalt. Some people say, well, how do you turn around and then get the liquid back out? Well, I can boil off the solvent, and this has been around for a while, but these are newer machines because these are automated machines. So I'm just gonna let you see just a few things and what it looks like here. But I can I take around. It looks like it's just a washing drum, and I'll take my mixture and put it in there. When I'm done washing it, it's going to come out, and I'm going to centrifuge the fines out. So all these processes that I had before are automated. And that thing on the bottom right you saw was the distillation tank. What will happen? I'll just walk you through it here, and we won't go through the whole sieve or the whole video. But I'm going through and I'm putting my aggregate into this wash bin. Well, what this is it's just a sieve. It's an inner sieve and an outer sieve that you see. And I'm just going to get my weights on that. I'll put a top on it. And as I do this, I put all these tear numbers on a sheet, and then I'll go through and I'm able to calculate how much aggregate that's washed out. Now, what you're seeing right there is what came out of that's the wrap that's going in. That looked like aggregate, but that actually was wrap, and that's what a wrap will look like, especially a dryer wrap. Going to put it in. She's going to seal it up. As I'm doing that, she's going to line this thing, and I'm going to stop the video here. But what we have is she puts a filter paper in, and it goes through it. It washes it. It spins out the fines. It dries everything for you, so I don't have to put it back into an oven. And then while it's finishing up, it's going to recover my solvent. So I'm able to recover a good portion of my solvent and not having to go buy new solvent. After 1 hour, I pull my things out, I get my weights, and voila, I've got 1% asphalt. And notice this is not run under a hood. This is an incredible invention. That one's by Infratest. Another tool that Steve, you and I were looking at this the other day, and this is where I think that a big piece of the video world and AI world is going is pavement condition monitoring. We can simply use cameras, not like they've got versions you can use with your phone, but better yet, these are mounted cameras that's getting these downward images that you're seeing here. Once I get that video, I divide it into 5-foot increments, and then what you're seeing, it's taking that 5-foot section, 12 feet wide, and it's saying that's a block crack. So it's calibrated, so it knows the block cracking, it knows the extent. It found out that this is alligator cracking. Now that's at the joint, but I'm not going to argue that is beginning what the alligator cracking looks like. It also found more alligator cracking up here, and it could call this a transverse crack, but it's not going to redo it because it's already got it listed as a block crack. And then it will summarize all that in these bar charts that you see over here, and it will give me meters or length of cracking, and it will also give me area of cracking. It will calculate the PCI value and then give me a distress rating, and all that I can click on a data dump, and it's going to kick every bit of that out to me on a spreadsheet if I so want that. And it's interactive with a map, and I can zoom into it. So again, new tools that's coming our way. Let's talk about newer mixtures that are out there today. Balanced mix design. I say enough said, but some folks still haven't heard about it. That's simply where instead of having the old type 1, type 2 mixtures or type 3 or type ABC or 9.5, we go beyond that and we say this mixture has this much rutting resistance and it's this much cracking resistance. Some states will also say we needed to have this much skid resistance. High wrap. It's got to be engineered by using the tools that we mentioned above with a rut test and a crack test. We can't just put in recycled materials just to put them in. However, to think that we're going to say, hey, we don't want any recycled materials, we can't do that either. even the FAA that has not put in any recycled materials in their surfaces are going to be challenged. How can they incorporate something but yet do it safely, do it properly to where our airports can continue to function as they do today? Same thing for our streets and roads. One good place to put a lot of wrap is in base materials. The interlayer, we've already talked about that. That's been in place since 2000, but yet we struggle to adopt it. And what an incredible tool it is to reduce cracking. Why don't we use it more? Because we tend to want to do the same thing over and over and over. Thin lift surfaces are really coming big now, similar to that interlayer mixture, but higher air voids. And what it allows us to do, it allows us to put a thin lift and hot mix becomes an asphalt maintenance treatment too. It's not going to last as long as a regular mix. It may only last 5, 6, 7 years, but that's what it's meant to do. It's a sacrificial thin surface that's going down to give us a little bit of ride. On BMD, I want to take just a moment for those who aren't familiar with it. This is cracking on this vertical axis, and this is rutting. So if I go to the right, I have more rutting resistance. If I go vertically, I have more cracking resistance. If I'm in the red, it's going to rut, it's going to crack, not desirable. In the 70s and 80s, we had poor rutting resistance, but really good cracking resistance. Then we, and what was going on there, there's things we had changed on processes, but when we introduced Super Pave, we really made these mixes rigid and we moved it all the way down to the purple. We talk about swinging the pendulum back and forth. We moved it to poor cracking, but good rutting resistance. Well, it's not really the pendulum as much as we got a box and we've got to move this thing in the right direction. So we want to go for better rutting and cracking. And if you take a look, if I can, I'll get my pen to come on here and my laser pointer, there it is. This is an example where we took a 6422 and we used aramid fiber. I love putting fiber in mixtures. It makes everything better. Pardon my allergies, folks. But the products such as aramid fiber, bio oils, and so on, you'll hear more about. These are great products that allow us to be able to make these mixtures better. So I simply put that in without giving up my rutting resistance. Matter of fact, I move it from being this gray dot over to the blue dot. So I improved rutting and I improved my cracking resistance. Now let me come in with this PG70. Well, keep in mind, it's already really rut resistant, so I can't do much to make it more rut resistant. But when I put fiber in the green dot, it takes me up to the red dot. Look what it did on cracking resistance. So wherever, this is an arbitrary box that I created, but wherever you put your line, the goal is to move from here up, or better yet, move into this box. I came up with a, and I'm not going to spend a lot of time on this one at all, but this is one that folks may want to just take a quick picture of if you're interested. If you're having problems meeting ideal CT or Hamburger, you know what those are, and talk about how does it affect my density. I created this chart to help understand the lower PG, what it will do, higher PG, how it may help your Hamburg but hurt your cracking, time under heat or in a silo. It helps against rutting resistance, hurts your cracking resistance, may affect your density a little bit. Wrap hurts cracking, increasing dust will hurt cracking, help rutting. Again, that's why we call this thing a balance. All these factors are coming into place. the warm mix additives, the fiber, and again, how it all will begin to affect your outcome. I'm gonna move on through this one. Newer materials. We've talked about the reflective crack relief interlayer, using the fiber and making something that's really flexible to reduce cracking. The goal is to absorb about 80% of the movement of what's underneath, and then you put an overlay on top of it that can handle the remaining 20%. Modifiers. We've talked about fiber already. High polymer, Kraton is another modifier that's out there. Heim is really good. It's got pros, it's got cons, like anything. And it's a little harder to work with, very terminal dependent, but it is proven to add a lot of flexibility. There's combinations that you can do. You could lower the polymer. It's been argued that I can lower the polymer, add a lot of fiber to it, and get the same effect as what's going on here. So get creative is what I ask folks to do. Is get creative with these materials and create what you need for your area and for your processes. Bio oils, the soybean, the corn-based oils, they all work well, and they actually react with the asphalt binder. They don't just water it down. I'm not going to, well, this chart was research. It was done by the National Center for Asphalt Technology. One thing I always like to point out is, as of 2015, bio oils aren't even on the radar. They were being used somewhat in the background, but bio oils are very, very new product. These bio oils are soy-based and corn-based oils, again, that react with the asphalt binder. They make asphalt, they enhance the property. So we like that. Products to watch, BASF. Those from those that were born and raised in the 70s, 80s, like me, remember cassette tapes that BASF made. That's about the only thing direct to market they made. Otherwise, BASF is making the products that go on labels. They make the stuff that goes on a mouse. They make the adhesive that go in the construction industry. They make the things that hold plywood together, construction adhesive, on and on and on. They make life better, they claim. So now they come into our industry and they come up with a Gorilla Glue type of technology that can go in and begin to help us modify our roadways.
Hey, Phil, we got a question.
Yeah.
Can we know what are the limits for BMD? So I guess pushing the limits, like how much wrap you put in there, how much.
Yeah, there's one thing to talk about the physical test limits. I think where the question's going on this one is, when will these tests not pick it up? The Hamburg's going to do a really good job because it's a repeated load test. Your CT index is not a repeated load test. So keep in mind, it's not going to understand polymers very well. It can't pick up on all the benefits of fiber. And so the CT is what we call an index test. So what we have to do is, if we bring in a newer material that's not familiar, you should always validate it with an actual fatigue test to make sure that it's that what you're seeing in the CT is proper. For instance, I can take a really soft material with high voids and it may give me a good number. I can do that with recycle, and but it doesn't mean it's not going to crack in the field. So yeah, good point there. Realize there's limitations on these tests. Validate it with trials. Hamburg, very well proven, but overall, if CT tells you it's going to do well, it pretty much will. I mentioned about the BASF Betalast. I've actually put down several of these trials. One of the cool things about this, it's a crazy strong adhesive, really improves the bond to the aggregate. It lowers fumes. Why is that important? H2S is a really dangerous in the headspace of our tanks. So this acts as a H2S scavenger. You can learn more about this at the Betalast NA, stands for North America.basf.com. A lot of plastic work going on right now. If you want to learn more about plastic, just Google the plastic and NCHRP 9-66. There's work going on the track where they down in Alabama, and they've got similar projects up in a cold regions track at Min Road in Minnesota, where they're looking at high density plastic, which are these type of bottles, and they're looking at low density, which are the Walmart bags. Overall, I don't think anybody's coming out saying that plastic is making everything better. If anything, it probably making it a little stiffer. But in some cases, we're able to put it in with little change. So we got to be open-minded. If we can use our roadways for linear landfill, for instance, in some areas, not everywhere, but in some areas, we can get rid of some of these plastics without negatively affecting our roadways. We need to consider doing these things. Next generation is going to be telling us that the folks younger than us are saying, younger than me, I'll say that, is that, how can we be better stewards? Show you a few demonstration projects will be done. This is one on Dixie Highway. And what I like to show here is this is the control and this is cracking. Over here on the left, this is the control. And I help go out and I take a look at these, the crack counts. And I'll show you how this all blends in here. 622 feet of cracking per the total over the same length of area measure. This one has 282. This is one in Stafford and Plainfield, Indiana. This one, this test on our left, and I'll just show you quickly. This is a lab prediction. This is like what Ideal CT or an SCB test. And it said that the fiber mix is going to perform better than the control mix. Well, they put it on the roadway in 2018. By 2019, the control mix, the gray, was already had more cracking. So this bar over here is crack resistance, so higher is better. The bar over here, higher is not good. This is actual cracking. This one, look how fast it is climbing. For those folks that love to look at slopes, this one has a slope of 66, whereas this one had a slope of 5. So you've got a rate of cracking that's 12 times more in this control than what it's doing down here in the blue fiber infused pavement. So these products work, and the tests are pretty decent to predict the performance. Interlayer we've talked about before. This is a project from Taylor County where we went on and we put the interlayer down. I think this is one where I had showed this video last time. What happens when you put a 10-ton roller on a high asphalt, an 8.5, 9% asphalt, liquid asphalt mixture that's got a lot of fines in it. Well, it just rolls in place as you're seeing there. This mixture is very proven, flexible, but does not shove under a roadway. Does not shove under a load on the roadway. I'll get it out in a moment.
Easy for you to say, right?
Yeah, say that one fast. So what about high wrap? And I'm not going to go into the details of the design other than to say this is one with 36% wrap. The city said, here's our baseline. Actually, their baseline was these blue bars here. They had a 71 CT and they had a Hamburg of 7,200. This is a rut resistance index, so it's not an exact Hamburg number. It's a multiplier. They said, we want you to design something that's at least as good as this and at least as good as this. So we came in, we did some trials, and what we ended up with was something in between. But we did it with 36% wrap. We put it down. City of Lexington came and said, can we do this with 45% wrap? We did the same thing, and we came in and did the same thing where we said, yes, we can go back. We designed it and came in with numbers that matched what they were doing. Their goal was not to make it better. This first off, they just said, we just want to use more wrap without sacrificing performance. This one was using a combo of the bio oil and the aramid fiber technology, but had a 30% reduction in CO2. Huge, absolutely huge, because we're not having to remine aggregates. We've already got the aggregate. See if I can get this to. Well, hang on, Stephen, am I there?
Yeah. Well,
Okay.
your presentation somehow went away.
Yeah, it wanted to restart. Let me hit it here, and it's gonna kick it back up. We were right at the end, and all I was going to show you is a little drive by on it, and then we're done. So
Hey, so what's the maximum amount of wrap they'll allow in Kentucky in the surface?
there are 20 in the surface. They're about somewhere. It works out. It's 20% binder replacement, I think. So somewhere around 17% is where they're at. Um, and more in the base, of course, but around 17% in the surface. That's a pretty standard note. If you go and look at where wrap usage is across the U.S., it's holding in the surface. It's holding right in, or total by the state. It's averaging somewhere in that 15 to 20% number. So, and by the way, that's been flat, if not gone down, over the past 10 years. So we tend to peak in the wrap usage in about 2010, I think, somewhere in that timeline that we've gone down. So, what's going on there and why is that happening? We're gonna have to challenge ourselves to improve upon what we're doing.
North
But we got to do
Carolina.
it. We got to do it
North,
right and design it. Go ahead.
no, yeah, I was just going to say North Carolina DOT allow up to 40% wrap in their surface mix.
Really? Okay.
Yeah.
Yeah. And as you get in these colder states, they're gonna they're trying to figure out how in the world can they do this without sacrificing cracking. And North Carolina, you get in the mountains, and it definitely will do that too. Okay, I'm going to try to reshare here.
Hey, another question too, so we've been using fiber on some of our municipal projects here, and there are some states where fiber is actually accepted by the state. So all the mix that everybody makes has got fiber in it, so it's not a big deal. Is Kentucky a state where they've adopted the fiber
Yeah,
at the state level?
they have. They're actually by using BMD testing, they're allowing it on a project by project basis as a substitute for 7622. Will it do as good? And they're saying we believe it will. So I applaud them because they're actually using their balanced mix design test to begin to allow material substitutions. So yes, they more than allow it. They're allowing it to be substituted. This is the project where this is a control of 20% wrap, and over here is the 45% wrap. This was taken last year. The 45% wrap is actually outperforming the control on a PCI basis of about 5 points. These are the trials using the isocyanate, working well. They're going on 4 or 5 years old now. So, said all that to say, companies are lining up with new products, Steve. They come through, and what they're used to seeing is they put down a trial, 2 to 5 years, additional trials. They'll come with a special note. And I've done commercialization of these materials for a long time. And this is just the life cycle. By year 7 to 10, we'll begin to spec them. By 20 years, we're going to begin putting them into place. We can't wait 20 years. If we wait 20 years, the year's going to be 2044. Bill's retired by that time, I hope. But in 2044, you're only 6 years away from net zero carbon goal of 2050. We've got to bring in these new materials quicker. Agencies, the pressures on agencies, the pressures on everybody, understand how they perform, warrants on how to use them. How do you measure success? And we got to follow up on them past the first year. With that, big organization that I'm part of, Association Asphalt Paving Technologists, has a 100th anniversary this year. And this is sort of where the knowledge starts, I guess, for asphalt pavements, and then it spreads out from there. But a lot of the papers you see that come out and research comes from this organization, a good portion of them. So join us in Chicago. With that, I appreciate the time today. There's my QR code. Any other questions? And thank you all for your time today. And sorry about my PowerPoint crashing. That 300 megabyte overloaded it.
Yeah. So I don't see any questions, but we certainly appreciate you keeping folks, in the know when it comes to pavement. It's it's one of the largest assets owned by most municipalities, and to monitor how well things perform is the key here, right? So if things are not performing,
asset management, you got it.
Yep. And so having an accurate record of when things were done, who did it, who inspected it, all the information, so that we can, when it comes down, it's like it's 5 years from now, the thing's cracking. Is that acceptable? Did we expect it to last that long, or was it supposed to last longer? What were some of the things that contributed to that? Maybe it was cold, or so you got to try these things. We have to, right. We got to make sure everything lasts the way we expect it to. It is good that using high dosage of wrap in construction, we can know if that wrap was preheated or it was directly added to the pug. Is there any issue if we could wrap directly?
Oh, yes. Okay. Great question. Contractors, if you go to a contractor, now there's newer ones that's out today, but the average contractor, you say, hey, fire it up and put as much wrap in as you can. Go. They're going to back off somewhere between 40 and 50% because they'll burn their plant up. You can't dry the moisture out of the wrap. So the stuff I worked with was not pre-dried. There was a lot of control on the wrap. There was a double shaker. So we had control of the size of it. They did not preheat it. But as far as reusing it, you're correct. If I just continue to reuse a product over and over and over, it's going to get stiffer. Unless I put in a recycling agent. In this case, we call it bio oils. It's been argued that you should put it on the wrap first. And then from what I'm seeing in my laboratory, it does not have to go on the wrap first. It can be blended in with the liquid, and that's the traditional way we're doing it today. And then we mix with it. With that being said, when it all mixes back together, if we've restored it back to close to what it was originally, then when you mill it again, it's not older wrap. It's been restored back to what it was before. And those sections are down at the track in Alabama that I mentioned.
So that kind of answers another question. It's like, can we, you have 40% wrap in your mix, and then you mill it up, and then you use it as 40% wrap again. You're able to do that.
Yeah, you can. But if you continue just to grind that one pile up, no, you can't do that, because you're going to create more dust and more dust and more dust. That's why you've got to separate. And when you put the 40% back in, it's not the exact 40. You're probably putting the coarse version of the 40 back in. Yeah.
Right.
Yeah.
Yep.
A lot of dust.
All righty. Well, we're out of time. And Phil, thank you again for presenting a second month in a row. It's been great. Thank you. And thanks everybody for attending.
Well, remember to throw up the bat signal if you need it.
Yeah, there you go. Hey, so the June Lunch and Learn, the topic's going to be fiber mat, and it's Elisa Miko from Russell Standard, and our Lunch and Learn will be June 26th at 11:30 a.m., and you'll receive an email from us. So thanks again for attending. Phil, have a great day.
Thank you. You all take care, and thanks for letting me join you.
Bye. Very good. Bye.